Today we're going to learn some new vocabulary of something that you already know how to do or you've already been introduced to. We're going to talk about inverse trig functions, and we use inverse trig functions to figure out what the angle is. You've used this on your calculator. Like if I ask you to find the angle whose sine is 0.1234, you do second sine. If you remember second sine, and you see that little inverse sign in blue letters on my calculator, well, that means find the angle if you don't know what the angle is, but you know what the sine is. So here's some new vocabulary for you. There's something else that can be written if you want an inverse sine, and it's called arcsine, or arccosine, or arctangent. And there's also an arccosecant, arcsecant, and arccotangent, but we're not going to study those. We'll just study the arcsine, arccosine, and arctangent. It's the same thing as you already know. It's just new notation for it. So whenever you see the functions arcsine, arccosine, arctangent, it means the inverse of sine, cosine, tangent. And this is how I learned it when I learned this new vocabulary. The word arc means the angle whose. So if I see arcsine, what I say to myself is the angle whose sine is. So arc means the angle whose cosine is. What does arctangent mean? Hopefully you can fill that in yourself without too much thought. It means the angle whose tangent is. Arc, the angle whose. So for example, you'll see it written this way: theta, which is the angle theta is equal to the angle whose sine is the square root of 3/2. Well, hopefully you remember from the blue sheet that the angle whose sine is the square root of 3/2 is actually 60 degrees. And if you wanted to convert 60 degrees into radians, you just divide by 180 math frac and you get pi over 3 radians. And hopefully you remember from the blue sheet the angle whose cosine is the square root of 2/2 is 45 degrees. If you wanted to convert 45 degrees into radians, divide 45 by 180 math frac and you get 1/4 pi. So that's just new notation for something old. I would really suggest that you use your calculator to compute the angle when you get an arc question. So whenever you see arctan, you just pull out your calculator. It's great if you can remember the angle whose tangent is 1, and you might be able to remember that from the blue sheet. But make sure your mode is in degrees mode. And if I see theta is equal to the arctangent of 1, I just do second tan of 1. And that's arctan. Arctan is second tan, and that's 45 degrees. So it says find theta in degrees, so that's 45 degrees. And if you need to round, then you can round, but a lot of these you don't need to round. Well, what angle has a cosine equal to 1? Well, that's one of those unit circle problems. You could probably figure that out on the unit circle. Which one of these major angles has a cosine that's equal to 1? Well, it would be 0 degrees because this is 1, 0. But you could ask your calculator second cosine of 1, and it'll tell you 0 degrees. Now, what's the angle who has a cosine that's -1/2? Well, there's a couple of answers, but our calculator will. Arccosine is just slightly different than inverse cosine, but arccosine of -1/2 will give you the quadrant 2. Oops. You can't see that. Our cosine of -1/2 will give you a quadrant 2 answer of 120 degrees. So what your calculator says is the right answer for the arc questions, 120 degrees. You don't have to go through the whole process of getting a reference angle and then finding the quadrant 2 angle and the quadrant 3 angle. There's only one real answer to this, and that's 120 degrees. And we're going to study arc a little bit more in other chapters. So just trust your calculator on this. Now, if you do arcsine, second sine of -1/2, calculator will tell you a negative answer, -30 degrees, and that's right, because your calculator's right as long as you put it in right. And the arctan, second tan, and I'll use my fraction button on this because I was given a fraction. The arctan of negative square root of 3 all over 3 is negative 30 degrees. If you don't have the fraction button, you have to make sure you close up your parentheses after the square root of 3 up top. So that's negative 30 degrees. And the arc cosine of 0, well, that can be found on the unit circle too. That would be your 90-degree angle, because that point up there is 0, 1. So the cosine of 90 degrees. But you can just ask your calculator. Second cosine of 0 will give you 90 degrees. Whoops. So you can just do these. I would suggest you just shut this video off for a couple seconds and do these on your own with your calculator and see if your answers match mine. Second sine of 0.34. Looks like it's 20 degrees if you round it. And second cosine of negative 0.61. Looks like it's 128 degrees if you round it. And second tan of 1.14 is 49 degrees if you round it. And the arctan of negative 2.3 is negative 66.5. That would be negative 67, rounded to the nearest degree. Negative 67 degrees. So here are the answers for the other ones. And here are the answers here. Now here's something kind of tricky here. Find the exact value. Well, when you see exact value, I want you to think blue sheet, which means you probably will get a radical answer on this. Well, what is the exact value of the cosine of the angle whose sine is a half? Well, what I'm going to do is get the arcsine of a half. I'm going to get this angle first. Do what's in parentheses first. If you want to use your calculator, second sine of a half. Hopefully you remember that's 30 degrees, but you can ask your calculator, and that's 30 degrees. So they want to know the exact value of the cosine of 30 degrees. Well, from our blue sheet, or whatever way you want to remember the sine, cosine, tangent of those special angles, the cosine of 30 degrees is the square root of 3 over 2. Your calculator will not tell you that answer. Number 12, the exact value of the cosecant of the angle whose cosine, the angle whose cosine is the square root of 3. Maybe you remember this from the blue sheet. It would be great if you could. That would be 30 degrees also. Whoops. Sorry for all these things that come off. So here's your arc cosine and square root of 3 over 2, and that's 30 degrees. And they want to know, what is the cosecant of 30 degrees? Well, the cosecant is the reciprocal of the sine. So what that means, it's 1 divided by the sine of 30. Well, the sine of 30 is a half. So 1 divided by 1/2 is equal to 2. So that exact answer would be equal to 2. Be careful, you don't do what, let's see, the sine of 1 over 30, right? For cosecant, it's 1 over the sine of 30 from the identities. Okay, here's another vocabulary word for you, cofunction. Cofunction is an important concept this year. Any trig function of an acute angle, you have to be given an acute angle in all of these. If you look down here, you're given acute angles. Any trig function, sine, cosine, tangent, any of the 6 of an acute angle is equal to the cofunction of its complement. Well, this CO matches this CO. And remember, from geometry class, or maybe from middle school, you remember the complementary angles add up to 90 degrees. For example, 10 degrees and 80 degrees are complementary angles, right? Or 20 and 70, or 45 and 45. Complementary angles add up to 90 degrees. So what we're going to be looking at is the cofunction of these acute angles in this way. This is what a cofunction is. Co means complementary. Okay, if you're given a function called sine, that's how you really spell sine, not sin. The cofunction of sine is cosine. And the cofunction of the cosine, you just take the word co out and you get sine. the cofunction of a tangent is a cotangent. And remember, these all have abbreviations, right? Sine is sin, cosine is cos, and cotangent is cot, and tangent is tan. But all you have to do is tack on the letters co in front of it if it doesn't have them, or you take off the letters co. So if you have a secant given to you, the cofunction of secant is cosecant, which is abbreviated CSC. Okay, you're given a cotangent, so just take the letters CO off, and the cofunction of cotangent is just plain old tangent. I hope you see the relationship here. It's really not that hard. And hopefully you can get all the rest of these here. Cosecant, take off the CO. The cofunction of cosecant is secant. Oop, I forgot to put my abbreviations here. COT, SEC. Cosecant is CSC. Secant is SEC. The cofunction of sine is cosine. Cofunction of secant is cosecant. Cofunction of tangent is cotangent. So the cofunctions have the letter CO in front of it. Okay, so keep those in mind, the function and the cofunctions. Now what we have are just given angles, and we're going to find the complement. 35 plus what is equal to 90? Well, I think 35 plus 55 is equal to 90. Think. And 10 degrees and 80 degrees add up to 180. 70 degrees and 20. You can probably just shut off this video and go right down through all of these and get the complement. Let's see. 90 minus 63 is 27 degrees. 90 minus 50 is 40. 90 minus 60 is 30. 90 minus 45 is 45. Right? All of these are complements. Add them up and they add up to 90. What if you're given x? Well, how did we figure out all of these complements? All we did was we said 90 minus whatever this angle is. So 90 minus x, 90 degrees. And what's the complement of 2x? It's just 90 minus 2x. So whatever you're given, the complement is subtracted from 90. Now down here at the bottom, it says, write the expression as a function of. That means write it as sine, cosine, tangent, secant, cosecant, or cotangent. That's what a function is of an acute angle whose measure is less than 45. Oh, all these things. Well, if it's less than 45, I guess it must be acute. And then we're going to check our answers on the calculator to see how these work. Now watch this little math and magic here. If you have the sine of 73 degrees, well, we can find that on our calculator in just a second. But what that is also equal to is the cofunction. Well, the cofunction of the sine is the cosine. And then we take the complementary angle to 73. Well, 73 plus what? Plus 17 adds up to 90, I believe. So we're going to make sure that we're accurate here and see that the sine of 73 is actually equal to the cosine of 17. So let's take our calculators out, get the sine of 73. See what our calculator says. Okay, there we go. And now we're going to get the cosine of 17. Well, look at that. They're exactly the same thing. So what this is saying is if you have two functions that are cofunctions of each other, these two angles add up to 90 degrees. You're going to get the same answer every time. So if you have a tangent, the cofunction is cotangent, and the complementary angle to 48 degrees, I think, is 42 degrees. And let's check on our calculator to make sure the tangent of 48, which is that, is equal to the cotangent of 42. Well, that's 1 over the tangent of 42. And look at that. They're exactly the same. Cofunctions. And these are complementary. That's just a check. So the secant of 80 degrees must be the same thing as the cosecant. Remember, these are cofunctions. Secant, cosecant. 80, 10. So the secant is 1 over the cosine. Oops. 1 over the cosine of what, 80? Let's see what that is. All right, there's the secant of 80. And we're saying the secant of 80 is the same thing as the cosecant of 10. Let's see, 1 over the sine of 10. Look at that. They're the same thing. So here's a secant of 80. Here's a cosecant of 10. Next, a cosine turns into a sine. 65 complement is 25. Let's see, cosine is 65. Let's see if that's the same thing as the sine of, what do we say, 35 or 25? Oh, look at that. They're the same thing. Next, cosecant. Well, that goes to secant. 70 goes to 20. 1 over the sine of 70. See if that's the same thing as 1 over the cosine of 20. Yep, they're the same thing. So there's your cosecant of 70, and there's your secant of 20. And the last thing is the cotangent of 89 is the same thing as the tangent of 1 degree. So 1 over the tangent of 89, 1 over the tangent of 89. Hopefully that's the same thing as the tangent of 1. And it is. Good. So that's how we check our answer. But these are all functions. Remember when it says a function, you got to write a function out. And these are all acute angles less than 45 degrees. And then the other twist that you have with these problems is sometimes you have an angle that is not between 0 and 90. So like there's no complementary angle to 305. He's just too darn big. So what we're going to do is we're going to get a reference angle for this. So the sine of 305, well, that's a quadrant 4 angle. So we're going to just subtract 360 minus 305. Sine of 305 is the same thing as the sine of the reference angle, which is 55. Oh, but in quadrant 4, all students take chemistry, says it's negative. So negative sine of 55. And now the next thing we're going to do is treat it just like these problems up here. We're going to drop this down, and we're going to change sine into cosine, the cofunction, and 55 we're going to change into the complementary angle, which is 35 degrees. So there's our final answer. We're given a sine of 305. Let's see what the sine of 305 is. There you go. And then let's see what the negative cosine of 35 degrees is. Same exact thing. Whoops. Sine of 305 and the cosine of 35. So you have 2 steps here, and you can just get practice by these other problems. The first step is to get a reference angle. Right? That's what we got is first, is the reference angle, and we just took the sine over, and we had to make sure that all students take chemistry told us whether this is negative. This is just like what we did before. And then after we get the reference angle, then we get the complementary angle. So there's really 2 steps. You got to get a couple of angles here. In number 8, this is a quadrant 2 answer, or quadrant 2 angle, 110 is. So we have to subtract from 180. And the tangent of 110 is the same thing as the tangent of 70, except in quadrant 2, tangent goes negative. Says all students take chemistry. So that's the first thing, is to get the reference angle. The second thing is to take the cofunction, which is cotangent. And the complementary angle to 70 is 20. So we're going to check to make sure that our original tangent of 110 is equal to the negative cotangent of 20, negative 1 over tangent of 20. And they're exactly the same. Here's your cotangent of 20, here's your tangent of 110. So there's your final answer here. Next one, 660, that's even bigger than 360, so we have to drop this down by 360. So the cosine of 660 is the same thing as the cosine of 300. Got to take away 360 first, because it's more than one rotation around. Now we've got a quadrant 4. The reference angle for quadrant 4 is you're going to subtract 360 minus 300. So 360 minus 300 is 60. So that's the same thing as the cosine of 60. And since this is quadrant 4, cosine is positive. And now what we're going to do is we're going to change cosine into sine and change 60 into 30. So sine of 30 would be the final answer for that. The cosine of 660 should be the sine of 30. Let's see. Cosine of 660 Yep, that's a half. Same thing as the sine of 30. We know that's a half. So there's a couple of things. And now we have a cosecant of negative. Well, we've got a negative angle, so we're going to add 360 degrees. Instead of subtracting 360, we're going to add 360. So the cosecant of negative 60 is the same thing as the cosecant of 300 degrees, because we want a positive angle. You don't ever want to work with a negative angle. This is coterminal. You probably want to mark this. This is coterminal. This is the reference. And this is the the complement. All these vocabulary words. So the cosecant of 300 degrees, well, that's a quadrant 4 angle, just like number 9 was. So that is the same thing as the cosecant of the reference angle, which is 60. So we got the coterminal. We got the reference. Oh, and all students take chemistry. Says the cosecant, which is the reciprocal of the sine goes negative, so cosecant will also go negative. So negative cosecant of 60 is the same thing as the positive, or the negative secant of the complement, 30 degrees. So that would be the final answer there. So coterminal angle, reference angle, and then the complementary angle are the 3 steps if you're given something that is just outside of the range. So there's your final answer, negative secant of 30. And you could check this if you wanted to, but I think I'm getting long on this video. Let's go through 4 more examples if we can, and then we'll quit for today. So the secant of 275, let's see, 275, that's in quadrant 4. So we have to get a reference angle. Subtract 360 minus 275 and get 85. So that's the same thing as the secant of 85. There's a reference angle. And all students take chemistry, says secant and cosine are both positive. And the cofunction of secant is the cosecant. And the complementary angle of 85 degrees is 5 degrees. So there would be your final answer. The cosecant of 5 is the same thing as the secant of 275. Check that on your calculator. Oh, we got a negative angle, so we better add 360 to it so we can get a coterminal angle. So the coterminal angle is 250. So that's the same thing as the cotangent of 250. Well, that's a quadrant 3 angle. So we're going to subtract that from 180 and get the cotangent of 70. And because quadrant 3, tangent and cotangent are both positive, we make that positive. And then the cofunction of cotangent is tangent, complementary to 70 is 20. And that's the end of that problem. Next one. Oh, we got a negative angle. We better add 360 to it to get the 360 minus 250. Okay, so we got a coterminal angle. It's the same thing as the sine of 110 degrees. 360 plus negative 250 is that. This is quadrant 2. Oh, sine is positive. That's good. So now we're going to do 180 minus 110 and get the sine of 70. And the sine of 70 is the same thing as the cosine of the complementary angle 20. This is quick to check. Let's check this on our calculator. The sine of negative 250 is that number. And hopefully that's the same thing as the cosine of 20. Yep, same exact thing, which is the same thing as the sine of 70. They're all the same. Same thing as the sine of 110. They're all the same. That equals that equals that equals that. They're all the same. And then 650. Oh, he's too big. So we've got to subtract 360 from 650 and get 290. So that's the same thing as the tangent 290. Well, that's a quadrant 4 angle. So quadrant 4, you got to subtract 360 minus 290 and get 70. So that's the same thing as the tangent of 70 degrees, but in quadrant 4, tangent goes negative, so it's negative tangent of 70. And then we're going to drop this down to less than 45 by getting the cofunctions. So cotangent 70 and 20 is 90. So now let's check to see that the tangent is 650. Is that the same thing as the negative cotangent, negative 1 over the tangent of 20? Yeah, they're the same thing. So the tangent of 650 is the same thing as the negative cotangent of 20, same numbers, which is the same thing as the negative tangent of 70. That was the step beforehand. That was this step right here, negative tangent of 70. And then that's the same thing as the tangent of 290, which was that step before. So all four of those numbers all four of those are exactly the same, but what they want is an angle less than 45 degrees in the end. So there's our angle that's less than 45. We had to do a lot of things to drop it less than 45. And that's it for today.